Hi guys, I hope you are doing well. I am doing great. This is our next video, case number 3. We are still determining the value of a, b, c, and d. If you are given the cubic function ax cubed plus bx squared plus cx plus d. Okay, case number 3 looks at when one of the stationary points actually lies on the x-axis, right? It lies. It's a turning point, but it's also an x-intercept. You know, one stationary point lies on the x-axis. Now, what do we know about that? So we know that one stationary point lies on the x-axis, and we need to find this cubic functions equation. The cubic functions equation is given by f of x is equal to x cubed plus bx squared plus cx plus d. But also when you rewrite it, you can get it in the form of a x minus x1, x minus x2, x minus x3, taking note of the brackets that are involved there. Right, so yes, let's get on it. One thing that I want us to look at it, what does that tell us if one point lies on a stationary point? We have the graph to see that, but there's something that you might not necessarily see on the graph, and that if you have that situation, it means you have a repeated root. So where there is x is equal to 1 there, this position over here, it's not just x is equal to 1, it's x is equal to 1 and x is equal to 1. So you have repeated roots, so there are two roots there. Okay, let's get on with it. So our approach would be that of saying a x minus x1 and x minus x2. However, we're squaring it. Because it's a repeated root. There are two of those, So how does that go? We then have to find our x values. Our x values are x is equal to -2 and x is equal to 1 and x is equal to 1. You can think about it that way. But if you've thought about the repeated root, like you exactly know what that means, then you are good to go. So this would be x minus -2 bracket, this would be x minus 1 but squared, and if you square that, then it means that there would be another bracket that's similar, but we just don't want to write it. We can just square that one bracket. So therefore we have a x plus 2 and x minus 1 squared, right? Yeah, so at this point, if I expand that bracket for you, this one, you will realize that there are 3, and you will realize that this is the same as case. I mean, algebraically, if you think about the solving, it's almost the same. Because what you're going to do now, you're going to substitute that point, that would be point what? Please talk about, I can hear someone saying 0 and 4. That would be 0 and 4. So, going down a bit. Ooh, okay. So we can substitute that point. Okay, I'm sorry, I'll go down quite a lot. So we can sub the point 0 and 4 in our equation. Where there is y or f of x, we put that, and where there is x, we put 0. Then just going to be 2, and if you put 0 there, this is going to be -1 squared. This is 4 is equal to a 2 times 1 minus 1 times minus 1 is 1, or -1 squared is 1. This would look like 4 is equal to 2a. We can divide both sides by 2 like that, and then we will find that our a is 2, right? Our a is 2. So we are happy what we have. We now have 2 x plus 2 and x minus 1 squared. So you have to multiply things out. This is your opportunity to actually see how this looks like, because I didn't really write it in an expanded form. That's how it would look like. At this point, it's exactly this, very close to very, very close to case 2. So I know the result of the x minus 1 squared, so I'll start with that. That would be x squared minus 2x plus 1. And then I will have to sort of like multiply these ideas. So guys, if you do not understand how to do this multiplication, talk to me, otherwise you will be in trouble. I'm warning you up front. Okay, so if I multiply those, let me see. I don't think okay, I'm not going to multiply all of them out, but if you multiply them all out, you should get 2x cubed minus 6x plus 4, plus 4. And therefore our a would be equal to 2. Before I do that, let me write this as f of x is equal to 2x cubed plus 0x squared plus or maybe minus 6x plus 4, and therefore your a would be is equal to 2, your b is equal to 0, because they said find it, right? So you cannot just not find it. You cannot just because it's 0 not say it. You need to say it. C is negative 6 and D is 4, right? And D is 4. And now I think I still have time to give you your question. Please attempt the following. Maybe it's just one. Your graph looks like a graph that I haven't drawn so far in terms of the a is negative, or not drawn, looked at. So that's your, so your a is negative, so your graph does this, then it goes there 3, then it turns somewhere there, and then it goes all the way down. Not the beautiful graph I've ever drawn. This is going to be minus 1, this is going to be 3, and this is going to be 2. The function is g of x, and then let me write the instruction. Probably determine f of x. That's not nice writing it there. Determine f of x where you're given what? You given ax cubed plus bx squared plus cx plus d. Boom. Please do that. Please do that. Okay, I am done. See you in the next video. I'll be looking at case 4.